So if you remember, we had said that 1 times 1 equals 1, so 1 is a perfect square. 2 times 2 equals 4, so 4 is a perfect square. 3 times 3 equals 9, so 9 is a perfect square. So we need to find the perfect squares. They're the one that comes before and the one that comes after. So here, the square root of 4 would be before, and the square root of 9 would be before. So we're going to have to give ourselves some benchmarks. So we're going to have to draw a number line, and we're going to place the square root of 4 and the square root of 9, and then we're going to be placing all our square roots. So square root of 5, square root of 6, square root of 7, square root of 8. I'm going to move this one a little bit closer. And the square root of 9. So we're going to be placing the square root of 7.5, and that would be just about here. Square root of 7.5, and that's what we're looking for. So now we're going to go at the bottom of our number line, and I know that the square root of 4 is 2, and I know that the square root of 9 is 3. So if I'm estimating the value of the square root of 7.5, I know that it's going to be somewhere in between 2 and 3. I'm going to give myself a little bit more benchmarks here. I know that right in the middle, that would be 2.5. And now if I'm estimating, 2.6 would be here, 2.7, 2.8, 2.9. So when we're estimating, we're not going to put an equal sign because we're estimating. So we're going to put the estimation symbol, and I'm estimating that the square root of 7.5 is approximately 2.7. We're going to do the same thing with the following one. So we're going to have to find the perfect squares, the one that comes before 10.9 and the one that comes after. So I know that 10.9 is in between 9 and 16. And we're going to be doing the same thing. We put a number line. We're going to put our benchmarks, square root of 9 here, square root of 16 here. So we're going to go square root of 10, square root of 11, square root 12. Now we're going to be placing our 10.9. So the square root of 10.9 would be approximately here. So square root of 10.9. Now we're going to go at the bottom. I know that the square root of 9 is 3, and I know that the square root of 16 is 4. So I know that the square root of 10.9, and we're estimating, would be in between 3 and 4. I'm going to give myself a little bit more benchmarks. I know that 3.5 would be approximately there. If I cut my number line, 3.1, 3.2, 3.3, 3.4, the square root of 10.9 would be approximately 3.3. One last example. If I have 20.9, I need to find the perfect squares, the one before and after. So 20 would be in between 16 and 25. We need to put this on our number line with benchmarks. So square root of 16, 25. Bring this one a little bit closer. So now we're going to be placing our square root of 20.9. The square root of 20.9 would be about here. And now we're going to go at the bottom. I know that the square root of 16 is 4, and the square root of 25 is 5. And if I look, I'm going to know that the square root of 20.9, remember we don't put the equal, we put the estimation sign, and 20.9 would be just about at 4.5. So if I'm estimating the square root of 20.9, it would be approximately 4.5. When it comes to fraction, so we're going to be estimating the square root of 5 over 8. So we're going to put our estimation sign. We're putting the square root. And now we're going to put for the numerator the closest perfect square. So the perfect closest square to 5 would be 4. And then for the denominator, we'd put the closest perfect square also. So the closest perfect square to 8 would be 9. And since we're estimating, we're still going to put the estimation. And now I know that the square root of 4 is 2. And the square root of 9 is 3. So if I'm estimating the square root of 5 over 8, it would be approximately 2 over 3. Same thing for the next one. So we're estimating, we put our estimation. We're going to put the square root symbol. The closest perfect square to 17 is 16. And the closest perfect square to 37 is 36. Estimation. The square root of 16 is 4. And the square root of 36 is 6. One last example. So we're estimating, put the estimation symbol, square root. The closest perfect square to 44 is 49. And the closest perfect square to 119 is 121. We put our estimation lines again. The square root of 49 is 7. And the square root of 121 is 11.